Hello everyone, how are you? I am fine, thanks to God. Now today we will try to discuss about the second chapter of data structure and algorithm, which is about algorithm analysis concepts. Four main concepts in algorithm analysis. The first one is or the definition of algorithm analysis. Algorithm analysis. The second one is the best or complexity analysis. Complexity analysis. Complexity analysis. The third one, measure of time. Measure of time. To complete a given algorithm or to run a given algorithm. The fourth one is asymptotic analysis. Asymptotic analysis. So in this chapter we try to address these four definitions or four main concepts related to algorithm analysis. So now starting from the definitions of algorithm analysis, what is algorithm analysis? What is algorithm analysis? What is algorithm analysis? So the definition says that algorithm analysis refers to the process of determining the amounts of computing time and storage spaces required for different algorithms. As we know, to solve one's problem, we design an algorithm, but the algorithm may differ from one individual designer to another individual designer. So to choose the best algorithm, we are we choose the best algorithm that fits our problem and our resource, what we have, running time and storage spaces. So in order to solve this problem, there are many possible algorithms, as we know. So what we have to do is that choose the best one. In order to choose the best one, we classify some data structure algorithms as good. We need precise ways of analyzing them in terms of the resources that we have. Basically, the running time, memory usage, and communication bandwidths. As you know, basic or fundamental resources in computing environment, fundamental or basic computing resources are, the first one is the running time of the algorithm. The second one is the memory usage of the algorithm. Memory usage of the algorithm. And the third one is the communication bandwidth. The communication bandwidth of the algorithm. So based on these three resources, we calculate, compute and calculate the best algorithm for our problems. This is the target or the definitions of algorithm analysis. There are two approaches to analyze or measure the efficiency of one's algorithm. The best or the two fundamental approaches that we choose or that we measure one's algorithm is the first one, the empirical computational analysis. Empirical or computational analysis. Analysis. So the first one, the communication or empirical analysis. What does it mean, empirical computational analysis mean? So starting from the definition here, the total running time of a program is first considered. The total amounts of the running time of the program is considered. However, it is difficult to measure how much the running time of a given algorithm or the designed algorithm is measured. But it is difficult, yeah. But what we to do here is that because clock time can vary based on many things of your hardware, running hardware, like the specific processor speed of your machine or computer or whatever any electronic device, the current processor load is a specific data for the particular program, input size of your problem domain, input properties of your problem, what is the input property of your problem, and the operating environments of your machine or algorithm varies or determines your computational running time. So it is difficult to measure the exact amounts of time in empirical computational analysis. How much the efficiency of the algorithm is. So the second one, the theoretical asymptotic complexity analysis. The theoretical asymptotic complexity analysis. Theoretical asymptotic analysis. These are the two approaches. Two approaches of algorithm, how to measure the algorithm. So what are the definitions or the meanings of the second one, or how we measure the time complexity of one's algorithm using the second approach or theoretical asymptotic complexity analysis? Determining what? The quality of the resources that you have. The quantity of the resources required mathematically, like execution time and memory usage and the like resources, that how much it needed by each algorithm. This is how the theoretical or the asymptotic complexity analysis works. So let, for example, consider f of n is equals to n squared plus 1. f of n is equals to n squared plus 5n. n squared plus 5n is a function that we wanted to compute for all n greater than 5. For all n greater than 5. For all n greater than 5. What we call for all n greater than 5, what will be the amount or the required time to compute this operation? For very large n, it becomes the 5n term is insufficient to compute the algorithm. So therefore, what we to do here, we can approximately f of n by the n squared terms only needed to compute this one. This is called the asymptotic complexity theory or analysis to measure the time required for a given algorithm. Good. Therefore, an approximation of the computational complexity that holds for large n, that means when the values of n becomes large and larger, usually it is difficult to determine computational complexities. So asymptotic complexity is the most common measure of time in algorithm analysis. From the first one, from the empirical analysis approach, the second one, theoretical analysis approach, is most common to determine the amounts of time required for a given algorithm to analyze the given algorithms. So complexity analysis is the systematic study of the cost of computational measure either in time, unit, or in operation performed from or for a given algorithm. Good. Good. What is complexity analysis? Complexity analysis. What is complexity analysis? Complexity analysis is the systematic study of the cost of computation measured either in time unit or in operation performed. The measure of time unit is either time unit or operation performed. Either in time unit or operation performed. This is the cost of computation measure. You measure here algorithm complexity either in time unit or the operations, how much the operation is performed. So what? Or in the amounts of storage space required, or the amounts of time storage space required. Storage space required. Good. So this is the complexity analysis. What complexity analysis means. The next one is the goal is to have a meaningful measure that permits a comparison of algorithm independent of operating platforms. Independent of the operating platforms. These are two basic things that we should consider. The first one is the time complexity. The second one is the space complexity. Good. Here, the two basic complexities or things that we consider is the first one, the time complexity, and the second one is space complexity. Space complexity and time complexity. What is time complexity? Time complexity determines the approximate numbers of operations required to solve a problem of size n. Number of operations required. Number of operations required to solve and number of what? Problems, and the number of or size of n problems. Size of n problems. What about space complexity? It determines the amount of or the approximate memory required. Approximate memory required what? To solve a problem of size n. To solve a problem of size n. Good. So this is the two things that we always consider for a given algorithm. Time complexity and space complexity. Complexity analysis involves two distinct phases. The first one, the algorithm analysis phase. The second one is order of magnitude analysis. What is algorithm analysis phase? The first one is the analysis of algorithm or data structure to produce a function of time n, a function of time t of n that describes the algorithm in terms of the operations performed in order to measure the complexity of your algorithm's performance. To measure the complexity of your algorithms or designed algorithms performance. Good. What is the second one approach or the second thing that we consider is the second phase, order of magnitude analysis. Order of magnitude analysis. What does it mean? Analysis of the function t of n to determine the general complexity category at which it belongs. Which belongs to. This is the two things or phases that we most of the time we analyze we analyze algorithm analysis and order of magnitude analysis. So what are the analysis rules to measure or to know your algorithm's performance? What are the rules? What are the rules? This is a basic concept to measure or to calculate or to know or to choose the best algorithm for your problem domain. To choose the best algorithm for your problem domain. Good. There is no generally accepted set of rules for an algorithm analysis. But however, in convention, an exact count of operations is commonly used to determine or to measure your algorithm's performance. So what is that rules? The first one is let's assume for a given program. The first one is executions of one of the following operation takes time unit 1. What thing is that it takes time unit 1? The first one is assignment operation. Example, sum is equals to 0. Sum is equal to 0 takes or counts time unit 1. The second one is single input. Actually, it is better to write here now. Rules of algorithm analysis. Rules of algorithm analysis. So the first one, assignment operation takes time unit 1. Assignment operation takes time unit 1. Like example, like what? And x is equals to 5. It takes time unit 1. The second one is the input-output operation. Input or output operation takes what? Time unit the same as 1. Example, see, we can say out less than algorithm and data structure course. Simply you can do this. This is the output operation. Or what? What? Like the above declared variable x. Simply x to change the values of x. This types of operation takes time unit 1. And the next one, single Boolean operation. Example, true or false. Boolean operations. Just we say single Boolean operations. Operations. What is example? Example for this types of Boolean operation is example. Let if x not equal to 0, and the output is true or false. Single arithmetic operation. Single arithmetic operations. Example what? Example for this types of operation, A plus B. It takes time unit 1. And function returns. The fifth one is function return. For example, for this types of operation is return 0. Return, don't say 0. Return sum or A plus B. return sum. These types of operations requires or takes time you need one. This is the 5 rules to set an operation having taking or assigning or giving time you need one. Time you need one. Okay, what about the second one? Okay, good. What about the second one? It for selection and looping statements. How much time we give? How much time we give? How much time we give for what? Selection statements and looping statements. This is the first one, single input output, or what time operations taking or assigning or requiring time unit one. What about for selection statements? For selection statements. Selection statements. If and what? If else statement is a switch statement is statements. For this one, for the condition evaluating plus the maximum of the running times for the individual clause in the selection statement. That means the options that the operation satisfies. For example, for the if statement, for the else statement, for the switch, the first case, the second case, the third case, for which one? So in this condition, we take or we give the value, the maximum single condition that we evaluate plus the maximum of the running time. Condition evaluation here takes time unit of condition evaluation plus the maximum marks of what the operations that we or satisfy maximum of the selection option or the conditions that satisfy. This is how the selection statement assigns a time meaning. The next one is running time for looping statements. So for this one, for running time for looping statements, we assign the running time for the assignment inside the loop times the number of operations that it may take place or performed. The total number of or running time of a statement inside a group of nested loops in the running time of the statement multiplied by the product of the size of all the loops, if you may have nested loops. If your loop is single loop, your multiplication times is single or one times. If you have two, you may multiply two times the loop operation. So what? For nested loops, analyze inside out. Always assume that the loop executes the maximum number of iterations is possible. You should take or you assume the maximum possibilities of the operations inside the loop. So running time for a function call, it also takes for set up one plus time for a parameter, any parameter calculation, plus the time required for the execution of the function body that you used or that you called. This is the rules of algorithm analysis. So to more clarify this definition or rule, we try to see each with example by example. By taking simple examples. Good. I think it is clear for you. If there is something difficulty or confused, makes you confused, please like me or put your comment on the comment section. For example, try to solve the time complexity of a given fragment of code. Let int count and count. This is the function, integer function, int k is equals to 0, k is equals to 0, cout, enter an integer, then cin what? N, then the next one, for loop, inside the for loop, and I is equals to 0, I less than n, I less than n, I plus plus. Then inside the for loop, k is equals to k plus 1, and finally return 0, or close your function body. This is simple or sample fragment of codes to show you how to compute the computational time of your algorithm. So what? Based on the rules that we discussed in the previous slides, we try to measure or calculate or compute the time complexity of the algorithm. So starting from the line number or from this line int k is equals to 0, that means assignment operations. We take t of n is equals to, let t of n is equals to, this is assignment operation, it requires time unit of 1 plus. The second one is the input output operation, it also requires time unit 1 plus. This is also cin or input operation, it requires time unit 1 plus. This is for loop. This is the for loop. So for for loop, what we was discussing in the previous slides, we nested it and add all this loop individual. So for input output, we also take 1 plus. For the operations, if it's operations, that means the condition check. For the condition check, we take n plus 1 operations, and for the increment inside the loop, we take what? We take on n operations plus n operations. Then what? Again, what here? n plus the next one inside the for loop. We have k is equals to k plus 1 operations. K is actually n is not known. It depends on the input of your integer value. So n times this operation is performed. So we have one assignment operator and one arithmetic operator, arithmetic operator. So we have what? 2n plus 2 times n operation time units, and finally we have the return statement here, return 0 also plus 1. This amount of time is required to compute this algorithm. So what? Let t of n is equals to 1 plus 1 plus 1, 3 here, as you know, as you see here, plus what? 1 plus actually here we can say 2 plus 2n plus 2n plus 1. 2n plus 2n, t of n is equals to 3 plus 2, 5 plus 1, 6, 2n plus 2n, 4n plus 6. Then 4n plus 6, t of n is equals to 4n plus 6, which is big of n. T of n is equals to big of and time unit required to compute this fragment of code algorithm. This fragment of code algorithm. This is a simple example to show how to calculate the time required to compute a given or this algorithm. I think this is clear example. This is the clear example. We take big of n, that means this is linear function. The function for n plus 6 is linear function. So your time required is expressed in terms of linear function, which is big of n. Big of n. I think this is clear concept. If there is some confusion or if you make you confuse this statement, please let me your comment on the comment section. Good. Another example. Let's see. I think it's better to clean this one and see another example to more clarify how to compute based on the rules discussed in the previous slides. So the code is starting from what? The code starts from by assignment operator k is equals to 0. K is equals to 0. Then cout enter integer, enter on integer, enter on integer. Then the next line is cin n operations or n input. Then the next one is the for loop. Inside the for loop, there is initialization I is equals to 0, semicolon, I less than some value n, semicolon, I plus increment 1 condition check. And then inside the for loop, k plus also here, k plus inside the for loop. And how to calculate this one? How to calculate this fragment of code? Time complexity or the time required to compute this fragment of code. So what? Q of n is equals to starting from the assignment operator k is equals to 1. It requires time bit 1 plus. Then the second one is the input output operation for this one and for this one plus 1 plus we reach for the for loop. For looping statement is we nest it and compute for each one. There is an assignment operator for I is equals to 0, 1 plus 4 is an if condition check operation. This one n plus 1 condition plus what? N increment is plus n. Then plus what? Plus till n operations. So to compute this, we sum up all this Q of n computations. Q of n is equals to 1 plus 1 plus 1 plus 1 plus 1, I think 5. 1 plus 3 plus n2, 2 plus 2n plus n. Then Q of n is equals to 2 plus 3 plus 2, 5 plus 4n, 5 plus 4n. Actually 3n, sorry. 5 plus 3n. Then Q of n is equals to 3n plus 5. Q of n is equals to big O n. Like because 3n is linear function, Q of n is equals to 3n plus 5 is linear function. It takes a time units of big O of expression. So this is how to compute. For this one and also for this one, it have or the both of them have time units of big O of n. But the steps are based on this. The computation is performed based on these rules. And also for while loop. This is for loop. What about for loops? For loops. While loops. How to calculate the computational time of a given for loop or a given while loop. So the fragment of code, the algorithm starts by assigning I is equals to 0. Then what? While loop. While what? While what? I less than n. I starts from 0. I less than n. Then here inside the while loop, x plus plus I plus plus. X plus plus or x increment and also I increment. Two operations here. Then next one out of the while loop, another while loop, what? Another while loop, inside another while loop, j less than or equal to 10, j less than or equal to 10, j less than or equal to 10. Actually there is another statement here, let me see it. J is equals to 0, while j less than 10, I think, yeah, less than 10. What we do inside the second while loop, x plus plus j plus plus, x plus plus j plus plus. Then how we calculate the time complexity of this fragment of the code? T of n is equals to, how we calculate this one? T of n is equals to, starting from the assignment operator, for I is equals to 0, it requires time unit 1 plus the second one, there is a while loop. For there is a while loop. For a while loop, we give a time complexity of n plus 1 operations because it is a condition check. Then inside the while loop, there is 2 iterations for x and j. So plus n for x increment and plus n for I increment. Then we finish the second while loop. For the second while loop, starting assignment operator, this equals 0 plus 1 plus. For the while loop, j less than or equal to 10. Actually here, n is fixed. That means n is 10. So for the while loop condition check, it requires time units of n plus 1. N plus 1 meaning n is 10, so it needs 11 time unit. And then for x and j, it requires n numbers of iteration. So for x plus 10, for j plus 10, and finally we calculate the time required for this fragment of code. So what? T of n is equals to 1 plus n plus 1, n plus 2 plus n plus n to n plus 1 plus 11, 12 plus 10, 21 plus 10, 31. Then what? Add this one. T of n is equals to n plus 2n, 3n plus 2 plus 31, 33. So it takes a time complexity of 33. T of n is equals to 3n plus 33. 3n plus 33. We go, time requirements. This is how to. Actually, there may be this one. 31, 32, 34. This is 34. Sorry, 34 times. It requires 34 times to compute this algorithm. Good. There is also for nested loops. How to calculate the nested for loop? For the nested for loop time complexity. How? Look. Example here, another example for nested for loops. Simply for the first for loop or for the outer for loop, I is equals to 1, semicolon, I less than or equal to n, I plus plus. Then inside the for loop, there is another for loop for what? Let's say j is equals to 0, j less than what value n, less than or equal to n, semicolon j plus plus. Then what? Inside the second for loop, k plus plus. Close the two for loops and calculate the time complexity of this for nested for loops. The time complexity for this time nested for loops. So what? Starting from the first one. For the assignment operation 1 plus for the second for the condition operation 1 plus n time units, and for the next one 1 plus n plus 1 plus, it is better to include or round 1 plus n plus 1 for the condition check, and for the next one, for the increment one, plus n plus, for the next one n into, that means the nested for loop requires n numbers of iterations depend on the first for loop. So n into, also apply the first one. That means 1 plus n plus 1 plus n. 1 plus n plus 1 plus n. 1 for the j is equals to 0 operation, plus n plus 1 for the condition check operation, plus for the j plus n for the increment one, plus what? For actually this is not closed here, this is enclosed here, and for the k plus n, another n. So we compute this one. T of n is equals to 1 plus n plus 1. That means 2 plus n plus n plus n into 1 plus n plus 1 plus n plus n into 1 plus n, n into, at the first one, 2 plus 3n. 2 plus 3n. Then what? The next one is actually yeah, we can do it. What you have to do is T of n is equals to 2 plus n plus 1 to n plus n times 2 to n plus n times 3n square. T of n is equals to 3n square, the largest exponent, 3n square plus 2n plus 1 for n plus 2. Then T of n is equals to, or it depends on the largest exponent of the equation. So T of n is equals to big of n square. This is how to compute the time complexity of your nested for loop algorithm. If your algorithm may contain for loop having nested loops, so you can calculate based on this scenario or based on this conditional steps. Good. The next step also another example you can do by your own. I will put all the exercises at the end of the video, and please set your output for exercise A, exercise B, exercise C, and DE up to DE. Your time complexity output, the last T of n value for each for A, B, C, D exercises, and the like exercise do by your own. This is all about time complexity algorithm analysis. In the algorithm analysis, time complexity, measure of time, very fundamental resources in computing environment, running time, memory usage, and other consideration communication bandwidth. So for today's video, we like and share. Goodbye. Please don't forget to subscribe Sami Tech YouTube channel for more updates and to get new videos. So please click on the bell icon to alarm you for new updates or new videos that I
Sami Tech YouTube channel. Like, share, subscribe. Computer programming, database administration, and other technological tutorials. Please like, share, subscribe. Sami Tech.